The Soviets were so satisfied with the results of their Sputnik program that in 1962 they launched a top-secret project to develop a self-sufficient moon base. The plan was codenamed Zvezda, or Star, and its objective was to take over the moon before the Americans. The objective was overly ambitious and called for the establishment of several habitation modules that would be half buried with regolith to conceal them. They would also be equipped with a wheeled chassis to reposition the base. Zvezda's development looked promising until disaster struck the N-1 human lunar expedition program. The powerful rocket that would carry the facility's components to the moon began suffering a series of crucial setbacks, and it looked like there was no other vehicle on the market that could be up to the task. That is, until a prominent engineer and designer came up with a potential solution. After the Berlin airlift of 1948, it became clear to the Westerners, especially the United States, that there were insoluble differences between them and Stalin's ideas of a new world order. In the years following the rise of the Soviet Union and the Cold War, Americans and Russians clashed in the arms and space race, as both nations sought to conquer the moon and outer space. On par with the nuclear weapons development, American and Soviet engineers commenced the development of ambitious plans to put a man on the moon. And while the Americans maintained nuclear supremacy, the Soviet space program rapidly gained the upper edge. During President Dwight D. Eisenhower's administration, the Soviets launched Sputnik 1 in October of 1957, becoming the first vehicle to be launched into space and the first to be put into orbit. American morale suffered a huge blow, and Eisenhower took the matter seriously. In 1958, the president dissolved the National Advisory Committee for Aeronautics, or NACA, which had been tasked with aeronautical research for the past decades, and created NASA. The National Aeronautics and Space Act began to focus on the space race from that point onwards. During this time, Wernher von Braun, the German developer of the V-2 rocket, became a pillar of the U.S. space program, and 1 year after NASA's establishment, his group began to draft the first pages of a lunar military outpost for the U.S. Army, codenamed Project Horizon. The moon outpost was expected to cost $6 billion and become operational by 1986. 12 soldiers were expected to monitor the moon and the Earth from the outpost, which would also deter Soviet interest in the lunar surface. The Saturn I and Saturn II rockets, still under development, were expected to resupply the base, and it was estimated that Horizon would require over 250 tons worth of construction materials. The project was developed in extreme secrecy, and very few people knew about the fundamental objective of landing on the moon. When John F. Kennedy assumed the presidency in 1961, he awarded more funds to NASA to develop new assets for the space race. The president publicly claimed that his administration was committed to landing a man on the moon within the decade, which was the Apollo program's objective. However, the Soviet space program shared the same objective, which was the nature of the Soviet crewed lunar programs like the Soyuz or Zond spacecraft missions, launched with the Proton K rocket. Like the Americans, the Soviets also believed it was feasible to establish a lunar base. And as far back as 1957, Russian professors from the Soviet Academy of Sciences had expressed that a moon base could be a reality sooner or later. In the early 1960s, following cosmonaut Yuri Gagarin's success aboard Vostok 1, Sergei Korolev, the brilliant mind behind the entire Soviet space program, took on the project to potentially raise an outpost on the moon's surface. Korolev discussed the idea with several scholars and specialists in 1962, and even published an article in Pravda, the primary publication of the Communist Party. However, the matter took a serious tone until 1967, when the Soviets were working on the powerful N-1 rocket, and thanks to Korolev's suggestions, the K-bomb Design Bureau began gathering information to establish a lunar base. The Bureau first contacted biologists, doctors, architects, astronomers, and atomic experts to study the project's feasibility. Then, in 1969, K-bomb issued a report titled Principles of the Construction of Long-Functioning Lunar Settlements, which proposed building a lunar base in 3 phases. The base would only be habitable for a crew of 4 at first, but would increase to 12 when the last section of the settlement was built. It would have a common area, an astronomy lab, a power supply center, a vehicle depot, and auxiliary facilities, and would also include life support, power, thermal control, communication systems, a gym, and a kitchen. The facilities would be buried under layers of regolith to conceal and protect them from meteorites and radiation, and its total mass was estimated at 52,000 kilograms, which would be delivered through the N1 rocket. In 1970, K-Bomb began building a full-scale mock-up of one of the lunar modules to test different technologies and assets for the project. Unfortunately, things didn't go as expected with the powerful N1 rocket that would carry all the materials required to build the Soviet moon base. After several launch attempts, the N1 project was suspended in 1974 while its engineers figured out what had gone wrong, and the K-Bomb Bureau was forced to stop the lunar base program until the N1 delivered results. Still, not all hope was lost for the desired Soviet moon base. Following the suspension of the N1 program, the government appointed Valentin Glushko as the head of Energia, the leading manufacturer and developer of Soviet spacecraft. Although Glushko vehemently wished to terminate the N1 rocket, he was pleased to continue with the creation of a lunar settlement. In 1974, Energia released a proposal for its own lunar base that was codenamed Zvezda, or Star, and that would be delivered to the moon aboard the new Vulcan heavy-lift rocket. This rocket could deliver 230 tons to low Earth, 60 tons to the moon's orbit, and 22 tons to the lunar surface, while the payload would consist of the LEK, or Lunar Expeditionary Complex, and a lunar transport craft. The LEK spacecraft consisted of the landing stage for the moon's descent, the ascent stage for taking off from the lunar surface, and the re-entry stage for returning to Earth. It weighed 31 tons and comprised a 20-ton laboratory and habitation module of 160 cubic meters, of which 25 square meters were reserved for habitation and 25 for laboratory usage. The module was 9 meters tall and had a width of little more than 8 meters. It was powered by a solar panel unit that could generate electricity. The third complex was a 15-ton laboratory and production module that stood 5 meters tall and gave access to a biotechnology and physics laboratory with a 3-ton oxygen-generating facility. The entire Soviet moon base complex would be powered by a nuclear power unit. A Lunokhod lunar rover was the last asset of the Zvezda moon base. The 8-ton vehicle, with a capacity for 2, would have a speed of 5 kilometers per hour and an approximate range of 200 kilometers. Before the deployment of the base, the desired zone would be meticulously mapped by an unmanned lunar spacecraft. Afterward, the base would begin construction in 3 phases, of which the first 2 would require 5 Vulcan rocket launches to carry all the equipment and essential materials. The last phase would take place 2 months after Phase 2 and carry the remaining laboratory equipment. Unfortunately, Glushko's ambitious proposal did not convince the Soviet government. After noticing that the Americans did not establish any moon bases during its 7 lunar Apollo expeditions, the government rejected the local project. Instead, the Soviets put their focus on copying the footprints of the American space shuttle. The project was also abandoned because it would cost at least $80 billion in 1980s currency. However, the Russians' ambition to establish a moon base did not entirely go away, and in the late 2010s, Russia's Federal Space Agency began gathering information to consider building a future base on the moon. The Lunokhod 1 made history as the first remote-controlled robot rover to roam freely across the moon's surface. Also known as Moonwalker 1 Device 8EL number 203, this robotic lunar rover was developed as part of the Lunokhod program, whose initial goal was to support the Soviet human moon missions. Lunokhod 1 arrived at the moon aboard the Luna 17 spacecraft in November of 1970. Its innovative technology recovered valuable scientific material and information related to the moon's soil. The rover sent over 20,000 images and 200 high-fidelity panoramas back to Moscow. Designed originally with a lifespan of 3 lunar days, the equivalent of 90 days on Earth, it withstood an astonishing career of 11 lunar days, almost an entire Earth year. Lunokhod 1 traveled 11 kilometers across the moon's rocky surface under a simultaneous 5-man control team. On September 14, 1971, on the anniversary of Sputnik 1, contact was abruptly lost with the vehicle. Failed attempts to reach it forced the Russians to abandon it. 40 years later, in late 2010, American and French scientists conducting remote research on the moon were astonished by the discovery of an unknown buried object. It was the Lunokhod 1, and its signal was more powerful than ever. The relic of the Cold War had made a strange comeback. Once the Soviet Union solidified its grip over most parts of Eastern Europe after the end of World War II, the Cold War began. By the early 1950s, the United States was startled to realize that their nuclear and military stronghold faced a new competitor. It was the USSR, and an arms race began. For almost 3 decades, both countries would go on a development rampage of military innovations whose sole objective was to overpower the enemy and shift the Cold War's balance. Closely related to this race for the ultimate display of force, a more peaceful competition rose between both countries. It was called the space race, and it reached its height during the 1960s. The United States and the Soviet Union engaged in a race to send humans to the moon as another way of displaying their tremendous technological developments. During the first years, the Soviets had the upper edge due to the initially successful Vostok and Sputnik programs, which were part of the Russian space program. The USSR sent the first human to space, Yuri Gagarin, in 1961 aboard the Vostok 1 capsule. It also manufactured the first 2- and 3-person spaceships. The Americans were successful as well. The American space program evolved into NASA, which produced the Apollo and Gemini programs, among others. Their ultimate objective was not only to send a man into space, they sought to land him on the moon. In 1968, after the deadly launch pad explosion of the Zond rocket, the USSR suspended all projects related to landing a man on the moon. The delay would be costly. In 1969, at the height of the Vietnam War, Neil Armstrong became the first human to walk on Earth's satellite. The US was unanimously declared the winner of the space race. The moon belonged to the US, and it looked like there was nothing the Soviets could do to stop the Americans from stepping forward. But an ambitious project was under development to prove that Russia still had some tricks up its sleeves. It was named the Lunokhod program, and its goal was to put remote-controlled robot rovers on the moon. The Lunokhod, or Moonwalker program, was part of a series of Russian robotic lunar vehicles designed to land on the moon. The first prototype, Lunokhod 0, was launched in 1969. It was destroyed during takeoff. The last prototype, Lunokhod 3, was scheduled to launch sometime in 1977, but it never came to be, and the project got suspended. The Lunokhods were designed to assist Soviet cosmonauts in their landings on the moon. After the cancellation of the USSR's manned landings, they were redesigned to function as remote-controlled robots for exploration and scientific research on the moon's surface. Lunokhods were transported to the moon by Luna spacecraft powered by Proton K rockets. The Luna 17 lander, carrying Lunokhod 1, was launched successfully from the Baikonur Cosmodrome in Kazakhstan on November 10, 1970. It made it to lunar orbit 5 days later and soft-landed in the flood basalt surface of Mare Imbrium, the Sea of Rains, on November 17th. Time magazine wrote about the robot's historic landing, quote, 3 hours after reaching the moon, aboard the latest unmanned Russian moon probe, Luna 17, Lunokhod 1 lumbered down one of 2 ramps extended by the mothership and moved forward, thus taking the first giant step for robot kind on another celestial body. NASA, genuinely intrigued by the curious Soviet vehicle, would also write about it in a summary of the mission, quote, Lunokhod 1 was a lunar vehicle formed of a tub-like compartment with a large convex lid on 8 independently powered wheels. Lunokhod was equipped with a cone-shaped antenna, a highly directional helical antenna, 4 television cameras, and special extendable devices to impact the lunar soil for soil density and mechanical property tests. The rover was also equipped with a cosmic ray detector, X-ray telescope, X-ray spectrometer, and a laser reflector device of French origin to measure the distance between the Earth and the Moon. Its body was hermetically sealed, filled with nitrogen at standard atmospheric pressure. The dome panel on top was hinged at the rear to be used as an insulation layer for the 3-week lunar nights. To face the moon's extremely cold temperatures, the Lunokhod was kept warm by a radioisotope that generated heat. Multiple cameras on the rover were used by a 5-man crew that coordinated to steer the vehicle in the desired direction. Driving was no easy task. The crew moved slowly, meticulously studying the terrain to avoid losing communication with Earth or collide with any obstruction. A 9th wheel, an odometer, was placed at the rover's rear to measure the traveled distance. The rover relied on thermal energy from a polonium-210 radioisotope heater to survive the night colds, when temperatures reached minus 150 degrees Celsius. The Lunokhod was solar-powered by day. Before conducting any operation, the vehicle opened its lid to charge its batteries. Given that the moon always has one side facing the Earth, daylight and nighttime hours on most spots of the surface last about 2 weeks. The rover was designed to last 3 lunar days, the equivalent of 90 Earth days. The Lunokhod exceeded the expectations of the USSR. It went on for 11 lunar days. The rover traveled 10.5 kilometers before contact was lost with Moscow on October 4, 1971, 14 years after the first Sputnik was launched. The USSR tried to reach it repeatedly, but failed to do so. The Lunokhod 1 was then forgotten in place of other projects. For 322 Earth days, almost a year, it had sent back 20,000 TV pictures, 200 TV panoramas, and information from more than 500 lunar soil tests to Moscow. In 2010, 40 years after the Lunokhod 1 lost contact with Earth, it was found by NASA and French scientists. A NASA press statement said, quote, "On April 22nd, Murphy and his team sent pulses of laser light from the 3.5-meter telescope at the Apache Point Observatory in New Mexico, zeroing in on the target coordinates provided by Lunar Reconnaissance Orbiter. A laser retroreflector on Lunokhod 1 intercepted the pulses and sent a clear signal back to Earth." The aforementioned Tom Murphy of UC San Diego, in charge of the research team that was trying to activate the Lunokhod, said to the press, quote, "We shined a laser on Lunokhod 1's position, and we were stunned by the power of the reflection. Lunokhod 1 is talking to us loudly and clearly. We got about 2,000 photons from Lunokhod 1 on our first try. After almost 40 years of silence, this rover has a lot to say." The American team could make contact because of 3 retroreflectors placed on the moon by U.S. Apollo astronauts during the 1960s and 70s. These were initially set to allow laser ranging of the moon's orbit. A 4th reflector was placed by Lunokhod 2, the successor of Lunokhod 1 that landed in 1973. Eric Silverberg, a retired veteran of the space race who was in charge of the lunar laser ranging activities at the McDonald Observatory during the 60s and the 80s, was astonished when he discovered that NASA had contacted the Soviet vehicle after 40 years. He said to the press, quote, "During that time, we successfully ranged all 3 of the Apollo corner reflectors and the Lunokhod 2 reflector. With Lunokhod 1 back in the picture, the U.S. research team could use laser ranging to dismantle Einstein's gravity theory. Murphy and his team were trying to, quote, see if we can break it. Einstein's theory of general relativity establishes that the mass and energy in massive objects, such as the Sun, make a space curve. This curving tells the objects around the massive body how to move. This is what makes the Earth and Moon fall toward the Sun. The Apache Point Observatory lunar laser ranging operation will continue further testing in hopes of finding a crack in Einstein's theory of general relativity." Lunokhod 1's success was followed by Lunokhod 2 in 1973, which drove for approximately 37 kilometers on the lunar surface, tripling its predecessor's range. For 40 years, no other vehicle landed on the moon's surface. It wasn't until 2013 that another robot explored the moon's surface, when the Chinese space program sent Chang'e 3 and its rover U-2. Although the lander U-2 could not move after its second lunar night, it remained operational for 31 months, surpassing the 11-month record previously held by the Soviet Lunokhod 2. A top-secret document describing a 1958 United States Air Force program to build an underground base on the moon was redacted right after the Soviet Union launched the Sputnik program. The Lunar Expedition Base has its objective manned exploration of the moon, with the first manned landing and return in late 1967. This one achievement, if accomplished before the USSR, will serve to demonstrate conclusively that this nation possesses the capability to win future competition in technology. No space achievement short of this goal will have equal technological significance, historical impact, or excite the entire world. While NASA would eventually develop its own plan to land a man on the moon, as so eloquently stated in President John F. Kennedy's 1962 "We Choose to Go to the Moon" speech, the Air Force didn't want to wait for a mere scientific expedition. Instead, they wanted the, quote, strategic high ground, and that meant having a U.S. military station firmly entrenched on the moon, well above its enemies on Earth. Before the Apollo program, a top-secret initiative called the Lunex project was hatched in the late 1950s. The U.S. Air Force sought to land the first crewed mission on the moon and developed a detailed schedule that would lead to an underground lunar base for 21 astronauts within a decade. The secret Lunex study reflected the Air Force's belief that, quote, the Soviets do not differentiate between military and non-military space systems. They have talked of a peaceful intent of their space program, but there are many pounds of payload in their satellites which cannot be accounted for on the basis of data given out. It should be presumed that this could be military payloads. From 1958 to 1960, the Air Force and industrial partners teamed up to examine the different angles of a lunar expedition, with the first manned landing and return in 1967. It was then determined that the problem of sending men to the moon and the techniques to achieve this goal were, quote, a feasible concept. Moreover, the objective was believed to be attainable earlier, as it was reasonably economical. Soon, the secretive program became a high priority, and a broad technological base was established at the Air Force laboratories. The Lunex project was not a race against the Russians per se, but primarily a plan to achieve a much-needed strategic high ground. After the launch of Sputnik in late 1957, industry Air Force teams conducted a series of studies to closely and realistically examine the military potential of space operations. The first study that supported Lunex was Lunar Observatory, a thorough review of a manned intelligence observatory on the lunar surface. A second research endeavor, called Strategic Lunar System, inspected the military applications of such facilities. Both studies unequivocally concluded that the venture was attainable and reliable. A third study, known as Permanent Satellite Base and Logistic, conceptualized the design of a specialized vehicle for a crew of 3 that would be able to re-enter and consequently carry passengers to and from the natural satellite. This vehicle would be the key item in the transportation system and demanded close attention, especially regarding its weight, as it would determine the necessary size for the boosters. With the objective to land 3 men on the moon as soon as possible, the due date was fixed for the third quarter of 1967, with the establishment of a lunar expedition by 1968. As the report concluded, quote, completion of this plan will require the development of equipment, materials, and techniques to transport men to and from the lunar surface, and to provide a lunar facility which will allow men to live and work in the extremely harsh lunar environment. The program's most important development would be a vehicle capable of transporting crews and supplies to and from Earth's satellite. The lunar transport would be composed of a space launching system and a payload, either manned or cargo. The manned lunar payload consisted of a re-entry vehicle, a launch stage, and a landing stage. The landing stage plus the cargo composed the cargo payload. As for the launching system, it comprised a booster in 3 stages, which could deliver either payload on a lunar intercept trajectory at escape velocity. Escape velocity was approximately 37,000 feet per second, enough to boost the 134,000-pound manned payload on a trajectory to intercept the moon and reach it in 2.5 days. When approaching the moon, the payload would use horizon scanners to reposition to a vertical relative to the locality. The landing stage would then decelerate it for a smooth landing at the pre-selected site, and terminal guidance equipment and a pre-positioned beacon would effect the offset landing. As for launching, the landing stage would serve as a base to impulse the Lunex re-entry vehicle back to the planet. Unmanned tests would need to be carried out beforehand, with automated countdown and launching controlled from Earth. Furthermore, minor mid-course corrections would ensure re-entry into the atmosphere, such as performing the return trajectory within the available corridor. Otherwise, the vehicle might skip back into space or burn from excess heat. By using aerodynamic braking, the craft could decelerate and land like any other unpowered aircraft due to its lift capability. Enough successful unmanned trials had to be completed before rendering the system dependable. In contrast, cargo could be transported similarly, but without the lunar launch stage. The package would weigh the equivalent of the Lunex re-entry vehicle and the launch stage combined. The recovery of a manned re-entry vehicle was set for 1965. The following milestones were to achieve manned circumlunar flight by 1966 and a complete manned lunar landing and return by 1967. The program had an approximate cost of $7.5 billion. If the United States had followed up with Lunex instead of pursuing the Apollo program, they would have built a launch vehicle resembling the shuttle by the end of the 1960s. In addition, the lifting re-entry vehicle, with its solid rocket boosters and LOX LH-2 core, would likely have provided a more stable basis for succeeding manned programs. But it was NASA's civilian enterprise that was favored over the Air Force's military program. Only after Apollo would NASA perform a radical revision of its technique, giving more importance to reusability and efficiency in the space shuttle. Lunex would also have strengthened U.S. military presence in space, even to the extent of changing the course of the Cold War. However, the program was overly optimistic. The booster and vehicle were considerably more advanced than the Apollos, and the first lunar landing was due soon. But the primary distinction laid in the orbital rendezvous maneuver. Lunex's approach concerned a Mach 35 lifting body spacecraft capable of re-entering and withstanding lunar hibernation for several months between engine restarts. The compound vehicle would even land on the surface in one piece, complete with its entire crew. In contrast, the Apollo involved a separate ascent module, which would leave the command and service modules. The module, with just one astronaut, would then connect with the lunar orbit. Moreover, the Lunex craft required electrostatic gyro platforms, but these weren't fully perfected until late in the 1970s. In addition, it also demanded computer storage data capabilities not yet achieved to this day. As was the case with all other Air Force space projects that involved manned missions, the outbreak of the Vietnam War likely stretched the service's focus, and it's believed that Lunex was eventually cancelled because of this. However, no efforts were in vain, as the top-secret report indicated, quote, "The entire program as described herein is an integrated program in that later development tests build on the results of early tests." Most historians agree that President Eisenhower was correct in establishing the National Aeronautics and Space Administration as a civilian agency the same year Lunex was born. Without it, a military-based space program would likely have turned outer space into an open battlefield. Almost a decade before Neil Armstrong took humanity's first steps on the moon, the American Air Force had a wild plan for Earth's natural satellite. During the Cold War, the United States and the Soviet Union tried to position themselves as world leaders in scientific, military, and technological prowess. This geopolitical conflict dragged on for nearly 5 decades. In 1957, the Soviets launched Sputnik and Sputnik 2, the first satellites in history, and Americans fell behind in the space race. To get ahead of the communists, the United States assembled a team of their best scientists, including recent grad school alumni Carl Sagan. The mission of this collective of geniuses: to figure out how to blow up the moon. Project A119 had no real functional purpose. The single goal was to show the world, especially the Soviets, that the United States could achieve something ambitiously spectacular through a giant mushroom cloud. Had the project come to fruition, Apollo 11 wouldn't ever have happened, and history as we know it would be drastically different. Although the concept of demolishing the moon seems unimaginable and downright crazy, all ideas were considered during the Cold War. In the late 1950s, feelings of paranoia and distrust ran rife. Scientific one-upmanship between the US and its arch-nemesis, the USSR, was one of the battlefronts in the war for global supremacy. On October 4th, 1957, the public was surprised when news broke that the USSR had successfully launched the world's first ever satellite, Sputnik. Only a month later, Sputnik 2 was also launched into Earth's orbit. Dr. Vince Houghton, a curator of the International Spy Museum, described the moment as such, quote, "The Americans and the West were terrified of the concept that, potentially, the Soviets had beaten us at our own game. We'd always been the big kids in science and technology, the people who invented new and innovative things. All of a sudden, the Soviets had beaten us into space." The ball was in the United States court now. The country needed to reclaim its authority and demonstrate that its technology was bigger and better than the communists. They needed a symbol, as big and fast as possible. That same year, Edward Teller, the inventor of the hydrogen bomb, wrote a project about outer space detonations. He proposed detonating at least one bomb on the moon, and another one near it, to test the lunar surface after the eruptions. He wasn't the first scientist to suggest it, and by the end of 1957, there were rumors that the Soviets were considering it too. A sensationalist piece in the Pittsburgh Press reported, quote, "The latest rumor going around is that the Russians plan to explode a rocket-borne H-bomb on the moon on or about November 7th. If that's true, look out. The rocket and its cargo of violence are more likely than not to boomerang." In 1958, the Air Force began assembling a team to see if this outlandish plan would be plausible. From the Air Force's perspective, the explosion would serve 2 purposes. 1, the blast's effects would be measured by scientists who would learn more about the moon than ever before. The other, perhaps even more important, a giant explosive cloud in space would be visible to the whole world. This would, undoubtedly, serve as a show of strength for America. Dr. Leonard Reifel was approached by the Air Force to lead the project. He had already held senior positions at NASA and was a close co-worker of Nobel Award winner Enrico Fermi, along with other world-renowned scientists. Reifel was intrigued and fascinated by the subject matter, even though the moon wasn't his area of expertise. In a 2000 interview with The Observer, he stated, quote, "The Air Force wanted a mushroom cloud so large it would be visible from Earth. The US was lagging behind in the space race. The explosion would obviously be best on the dark side of the moon. and the theory was that if the bomb exploded on the edge of the moon, the mushroom cloud would be illuminated by the sun. To know everything there was to learn about the moon, Rifle recruited Gerard Kuiper, a Dutch astronomer, planetary scientist, and selenographer. One of the last men to be hired was doctorate student Carl Sagan. His job was to accurately model the expansion of the dust cloud that would be caused by that kind of nuclear explosion on the moon's surface. The Air Force needed to know how big and visible the mushroom cloud would be. Almost a year and a half later, in the summer of 1959, Project A119 was presented to the Air Force in a report named A Study of Lunar Research Flights. The now unclassified, almost 300-page investigation contemplated all the scientific, military, and political pros and cons of a hypothetical atomic explosion on the moon. According to the report, quote, "A study was conducted of various theories of the moon's structure and origin, and a description of the probable nature of the lunar surface is given. The areas discussed in some detail are lunar optical studies, seismic observations, lunar surface and magnetic fields, plasma, magnetic field effects, and organic matter of the moon." Bombing the moon had a significant political benefit. The giant mushroom cloud image would imprint itself into the entire world's minds, and the Soviet Union would fall behind in the space race. Sputnik and its successor would seem like child's play. But the document isn't exactly clear on how the warhead would make its way to outer space. Considering some of the chapters were cut out or redacted, not much is known about the specifications a rocket would need to carry a bomb to the moon. However, the report does suggest a missile carrying a nuclear device would be launched from Earth and travel 238,000 miles to the moon, where it would detonate upon contact. Scientists discarded the possibility of a hydrogen bomb, as it would have been too heavy for a missile. The conclusion was that an atom bomb would be the better choice. The weapon would have been at least as large as the one used on Hiroshima at the end of World War II. The Air Force scrapped the plan entirely before it was even formally considered. And although there isn't an official reason why A119 was scrapped, there is plenty of speculation. Even if the Air Force had done all the math correctly, there was no absolute way of knowing what could happen to Earth should the mission fail. There was also the possibility that bombing the moon would be seen as an act of military violence, rather than a show of scientific prowess. Fear at the likely public outrage might have been a powerful reason to stop the project. As Dr. Rifle said, quote, "It was a PR device, without question, in the minds of the people from the Air Force." The scientists' concern about radioactive contamination from the moon could also have been one of the deciding factors in canceling the program and eliminating the possibility of any future missions with space warheads. In the years that followed, Congress passed 2 different bills that would further limit these kinds of attacks. The first one was the Partial Nuclear Test Ban Treaty in 1983. The second was the United Nations Outer Space Treaty in 1967, which over 100 countries signed. America rose as the space race winner almost 10 years later with the iconic Apollo 11 mission. On July 20th, 1969, the world watched, astonished, as Neil Armstrong became the first man to ever set foot on the moon. Dr. Rifle became the deputy director at NASA for the Apollo program. Then young graduate Carl Sagan became an American global icon of science, with a television show and several published books. A study of lunar research flights was designated as classified information and stayed hidden from the public for decades. It wasn't until the mid-90s when biographer Kay Davidson found out about the project while researching for a book about Sagan. The project came into public attention in the year 2000 when the book was published. This led Dr. Rifle to break his anonymity as the project's leader. He gave an interview to The Observer, where he revealed details about America's unusual lunar plan, but didn't specify how the explosion would have taken place. He said, quote, "Had the project been made public, there would have been an outcry. There's no doubt that had Project A119 been implemented, modern history would be vastly different. The moon is a source of scientific and artistic inspiration for people worldwide, and the thought of it not existing is mind-boggling." According to Vince Houghton at the International Spy Museum, the explosion wouldn't even have looked the way the Air Force expected. Due to the lack of atmosphere, instead of a mushroom cloud, the world would have only gotten a flash of bright light. British nuclear historian Dr. David Lowry said about the project, quote, "It is obscene. To think that the first contact human beings would have had with another world would have been to explode a nuclear bomb. Had they gone ahead, we would never have had the romantic image of Neil Armstrong taking one giant step for mankind."